Welcome to this course on data structures and algorithms. In this particular session, we will continue our discussion on implementing a bus queue. We have already seen the demonstration of a simple bus queue. We will recall that in this example, we had assigned arbitrary timings for people joining the bus queue, arbitrary timings for buses to arrive, and then people leaving the queue and joining the bus. In this particular session, we will look at a computer program which implements that particular simulation of a bus queue. First, we discuss the data structures that we require to simulate the bus queue. As agreed, we will use queues to represent arrival of passengers. So, each passenger is given a unique ID. This is an artificial ID, and this helps us to identify the person who leaves and calculate the corresponding waiting time, etc. Each person is also assigned an arrival time. Again, for now it is done arbitrarily. So, we will store this information in a structure called personal info, which contains the people ID and arrival time that arrive and stand in the queue. Next, we require a queue which we call the bus queue. Now, our queue is of the type structured personal info. Why? Because each person will be standing in the queue and each person is represented by an artificial ID and an arbitrary arrival time. So, the queue will be of type structure. It contains information about all the people as above. Let us look at the additional functions that we have to write now. Please note, these are over and above the functions which are already available as standard template library queue functions. Now, the functions that we will need would be required to handle A, the arrival of a person, and B, the arrival of a bus. Person arrives, it is a very simple function. All that we need to do is push the information of the person on the queue, that is bus queue, which includes person ID and arrival time. Boarding the bus is slightly more complex. We will have to handle in this function the arrival of the bus. Then, depending upon the available seats in the bus, people in the bus queue will board the bus. We will calculate the wait time for each person, and we will note that if the bus arrives earlier and has not departed when a person arrives, of course, the wait time is 0 for that person. Now, these two simple functions we will have to write in addition to using the standard queue functions. So, let us look at the implementation of this bus queue. First, we define the struct personal info. Person info is very simple, person ID and arrival time. We note that the person ID will be arbitrarily given by adding one number in sequence for every new person arriving, and arrival time will be arbitrarily decided. The class bus stop is defined with a private member data static int ID. How do we use this? This number we will use as the base number to generate the sequence of person IDs as people arrive. We next define the queue, which is person info bus queue. In public members, we have the void person arrives with time as a parameter, and void board bus, this has two parameters, the bus arrival time and the available seats for that particular bus. This is all there is to the definition of the class bus stop. We note that we have an int bus stop : ID equal to 1000, an arbitrary number which is used as a base to start assigning the ID numbers to passengers who arrive. Next, we have the person arrives function. So, we say void bus stop : person arrives. Note that the parameter is time. So, when the given time is, it comes to this function, we define the person info as a person and we assign the plus ID to person ID. So, if our base was 1000 for example, each person who comes in will be assigned in sequence 1001, 1002, 1003, 1004 as arbitrary ID. The time which is passed on to this function is the arrival time, and that we assign to the person dot arrival time. We know what to do now with this information. We have to push this person onto the queue, which means we have to push the information about person ID and arrival time. All that we need to do is we say push person. We will just print out information about that person, is the person ID and the arrival time. This is a simple function that we need. Next is a more complex function where we implement the boarding of the bus. You will recall our discussion on various things that need to be handled when somebody boards the bus. Please note that this particular function has two parameters. One is the bus arrival time and the other is the number of available seats in that bus. We initialize some variables at the beginning like count is 0, etc., person arrival time is 0, etc. At this place we will write the code for boarding the bus. This code is given on the next slide. Here I am just describing the overall structure of this function board bus. So, once the code is executed for boarding the bus, we will simply output the count, the number of people who have boarded the bus, and if the bus queue is not empty, we will just print out the next person in the queue who is still waiting. This will be the bus queue front at this moment and the person ID, otherwise we will say nobody is waiting in the bus queue. So, this is the function. Of course, we still have to write the code for boarding the bus, which is explained here. Now, there are people who are waiting in the queue and there are certain number of available seats. The logic that we use is we run an iteration for I equal to 1 to the number of available seats 2, 3, 5, 8, whatever it is. Now, at every iteration we will check if the bus queue is not empty, that means there is a person waiting. If there is a person waiting, we note the person arrival time from the bus queue front dot arrival time. If the arrival time is of the bus is less than person arrival time, we know that there is no waiting time, but otherwise the waiting time is calculated as bus arrival time minus person arrival time. We output the waiting time of that person by printing the bus queue dot front and then we output the waiting time. We increment the count and we do not forget to pop the top person from the queue. Why? Because the person has already boarded the bus. So, please note how simple it is. We run an iteration for 1 to available seats. If the number of available seats are more than the people in the queue, everybody will be accommodated. If not, some people will still be left in the queue. This completes the simulation for boarding the bus. Our main program is very simple. We define bus stop as say B stop, a variable. So, this is an instance of the class bus stop. We define bus arrival time. Now, look at our arbitrary assignments. I repeat again that in actual simulation the person's arrival time will have to be randomly generated, but to be consistent with the illustration that we had given in the last session, we just arbitrarily assign value 14, 15, 14, 19, 14, 21, 14, 22, 14, 27 as the arrival time of different persons. Since we had shown 5 people arriving, we call this function 5 times. Next, we know that 2 buses arrive in our illustration. So, we put the first bus arrival time as 14:30, we print that information and then we call the board bus function. We note that when the board bus function is executed, since there are only 2 seats available, only 2 of the 5 people in the queue will board that bus. The next bus arrives at 14:40 as per our illustration. So, we print again the bus arrival time. This time there are 7 seats and as we noted in the illustration, everybody in the queue will be accommodated. This is the end of the main program. This is the sample output that you will get. Person number 1001 arrived at 14:15, etc. 1005 arrived at 14:27. The first bus arrived at 14:30. Waiting time of individuals was this much, 2 people boarded. Next person in the queue was 1003. Next bus arrived at 14:50 and then their waiting times, 3 people boarded the bus, nobody waiting. So, you see it is extremely simple to use STL queues to simulate real life queues. Of course, as I mentioned, in real life we will not be able to give arbitrary arrival numbers, arbitrary number of seats available in the bus, and this I once again request you to look at the practice problems that we will be putting up shortly so that you could solve them. We will eventually put the solutions of these practice problems also on the IIT Bombay X. To conclude, in this session we looked at a C++ program which implements our illustrative example of simulating a bus queue. We also note that in this illustration we have used arbitrary timings of arrival of people and arbitrary timings of arrival of bus and arbitrary number of seats available. In real life, these will all be replaced by generating appropriate random numbers representing what we call the probability distribution of the arrival of people and arrival of buses. Thank you very much.